boy, do we have a treat for you guys.
Let's hear about it.
Now we're going to be discussing the Lunar Rover on Apollo 17, or in fact, in any Apollo mission. But we're going to concentrate on 17 for now. So, I was going over a document with Raza a few days ago. Raza was wondering why this rover traverse over here has the video feed coming from the camera while the rover is moving. We've seen that one. This one guy starts on his channel and he's giving him a bad time. Now he's claiming that the Apollo rover, just on 17, had a tracking system installed on the S-band dish. So I'm going to read this one little paragraph here. It said, how the communication worked. Antenna on the Lunar Rover. The LRV was equipped with a high-gain directional antenna that was designed to transmit data and video back to Earth. This antenna, although directional, could be kept in a general direction of Earth by relying on a tracking system that allowed for some compensation as the rover moved. So, this is a little excerpt from a document that he sent to Raza, I believe. So now let's go over here and have a look at the rover diagram in NASA's little PDF. Now we're looking at page 48 in this PDF on the rover. Now, I'm looking at all of the hardware on this tracking system. I can't find a tracking system here for starters, but it says Figure 4-7, pointing high gain antenna. So I go over here and I'm looking at this and I'm looking at all the parts down here and up here and here. Oh, wait a minute. Let's just do one better. Let's go to the parts list and we'll have a look at the parts list. Now let's open this up and let's have a good look at all that listing there. The rover starts at page 48. Now we're going to go to page 49. And it gives you all the little pieces and parts here and over here, tells you what they are. And it says this little toggle here was set at launch in a folded position. And this is to actually grip. This is a handle to grab so that you can align the dish manually. Then we look at this alignment lock nut right here. Well, if they're going to put a motor in there, the motor on a dish goes right up here and it sticks out this way and there's a worm gear inside of here. I've set up a few of these dishes in my time. Not the rover, but just the standard 20-foot dishes. There's always a worm gear right up there and the motor sits right here. And that's what spins the dish laterally. Well, I don't see any motors here. There's no motor in the list. This is just lock nuts and the wire going up. Oh, and by the way, here's the connection right over here, and it comes up, goes up to the LNA, to the horn feed. But you notice that there's only one wire, and that one wire, guess what that carries? The signal. And then you might say, well, maybe this is the motor or one of the motors right here. So let's go and look a little further here. Oh, by the way, there's no mention of a motor anywhere here in this parts list. Then we go down one more page. And let's see what that page says. Oh, that's no motor. That's a dust cover for the scope to align the angle of the dish up with.
Basically, you point it at Earth and you can get it aligned with Earth.
Precisely. So what you're basically doing is you're setting this up to the Earth-Sun angle. And what it does is it actually gives you the degrees right here, the Earth-Sun angle on here and on here in page 46. But if we go further, we could take a look and we could see the thermal blanket that goes over it, the Velcro thermal blanket, which has to be removed before you can look into it. Now we're going to the low gain antenna on the LCRU handy carry mode. Well, so far, I haven't seen any motor mentioned anywhere here in this PDF because the rover actually starts right here at page 46.
If you have a locking nut and you lock the nut, then the motor wouldn't work anyway.
As a matter of fact, let's just go over to the rover itself, right over here. And we're going to open this guy up. There's the little locking mechanism here, the locking handle that adjusts the dish this way and this way in the arc. And there's the handle that you use to move it so that you can get the arc. There's the wire going up for the transmitter to the dish, but you don't see a wire going up for any motor. In fact, you don't see a motor up here. So my question, how is this dish tracking anything while that rover's moving? And if you want to see something better than that, we can even start it up and we can watch this dish bounce around all over the countryside.
Robert, that's one of those newfangled Armstrong motors. Use your arm, Armstrong motor?
Yeah, it's an Armstrong motor.
Don't need wires on it.
But that's my whole point here. You see, there's nothing. There is no motor or set of motors on the dish. There's nothing there. So let's go take a look at Apollo 17 rover stills, because that's what we were just looking at earlier. Oh, wait a minute. Again, I thought he just said Apollo 17 had this tracking system on it. Well, there's no motor. There's the lock nut. And even if there was a motor or two motors, how is it going to work when you twist that lock nut closed? It's not going anywhere. And where's the voltage wires? Well, where's the other wire here that's supposed to be for the voltage to the motors to turn them up and down? There's nothing here. There's not even a servo system up here. This wire, again, only goes to the LNA, out to the transmitter. That's all we see. So whoever it is that's telling Raza, giving him a bad time, let's take a look and see who it was that was saying these things. And let's take a look at who sent this trash. So we have Kevin W. Parker, who said to Raza Vihari, he said, one scene 11 seconds long, driving straight where the antenna managed to briefly remain aimed on Earth sufficiently for a signal to get through. Hardly a smoking gun, particularly when no one could come up with the provenance of this video. Well, the provenance of this video is Apollo 17. That's the first time that this was mentioned. And if you look at the hills behind it when I run the video, you will notice that the hills match the Apollo 17 footage and pictures. So this rover was from Apollo 17. And he's asking for information on, well, how do you know that? Well, I'm going to match the hills for him. But my point is that these are the kind of guys that will come up with all these silly documents and they have nothing to back it up with. Because when we pull the originals up, we notice that the rover doesn't have any motors, no tracking system. That was the Apollo 17 rover that I was just showing you. Where's all of this tracking stuff? Where's the tracking hardware? Where's the motors? Where's the control wiring? There isn't any.
Well, you see, when you're on the lunar surface, the Earth should be almost directly overhead. And look at the angle of that antenna all the time.
By the way, where's the DAC camera on some of these pictures?
Oh, there's no DAC camera on Apollo 17. Even though they've got DAC footage, but there's no DAC camera on board the rover. I just went through all of the rover images. No DAC camera on board. But the Earth should be almost directly overhead.
Here's another thing of interest that I wanted to bring up too, about these dishes. So let's just take a look at some of these satellite dish setups over here. Here is a video of a satellite dish while it is going through the Clark arc function, locating all the satellites. So this is auto programming right now itself. And now it's picking up some of the satellites, right down here. Then we go over to here. Now, this is an interesting piece of equipment because it tells you where those satellites are so that we know which coordinates to punch into that Clark arc feature. And not only does it do that, but it also gives you the strength of the satellite, where it's located, all that stuff. Now, of course, this has a tracking motor on it. We can see that this has a tracking motor on it because it's going through its little procedure over here. Oh, by the way, you see the motor at the end of that little tail there? Well, that's where that motor would be on that dish. We don't see it anywhere. But there's also wires going to that motor. We don't see that over on the Apollo dish. And we're told that these dishes over here, there's the dish right there with all of the connectors and everything on it. Once again, we don't see any motor. We don't see any wire coming down here. We don't see anything except for the wire going up for the signal.
Well, when you're looking from the lunar surface back to the Earth, 1 arc second is 1.9 kilometers. So you have 60 of those in 1 degree when you're looking at it. So they claim that they have a 5-degree range of angle in which to set that antenna up from the lunar surface back, a 5-degree angle. Now you're looking well over a 300-mile dish, or an array of dishes that would cover that much area on the Earth, but it would have to be portable because the Earth is rotating all the time. That's why when you see other documentation, they were talking about planar antennas, which computer controlled, can be dialed in to adjust the angle as the Earth rotates. These didn't have that. Of course, they claimed that on the Surveyor. When we started talking about the antenna on the Surveyor, all of a sudden it has a planar device, which is not visible because it's just a piece of particle board. Literally a piece of particle board. These antennas, to be there, you would have to be within 1 arc second, and there's no way that they can do that using a visual sight to the Earth to get within that. I mean, that's why here on Earth, when your satellite antenna goes out, you have to call the guy, because he has to come out with that little machine and dial in the signal as he first figures out where the satellite is coming from that his dish is locked onto. But then he pulls the signal in to do that, and that's only 100, 150 miles away from you. This is 250,000 miles away, and that 1 arc second is 1.9 kilometers in distance, the range of that. So you have to be 1/100th of a 1 arc second to get into the range that you need to be in. They can't do that visually, but they claim this dish is variable for 5 degrees, which is ridiculous.
Yeah, and they did it visually.
Yeah.
Yeah.
You could miss it by hundreds of miles.
It was sighted through a sort of telescope type device so that the dish on the rover would line up with Earth. Now, Earth itself from the moon has 2 degrees of visibility. If you're outside that 2 degrees, if you're over there somewhere, it's not going to pick up on Earth. You have to point it at Earth. Now, when you point it at Earth, you will be received by 3 antennae on Earth. Goldstone in California, near Madrid in Spain, and in Australia at Parkes. Those are the 3 antennae on Earth which were receiving, allegedly, signals from the moon. But if you're going to try to transmit video signals, you have to get your line of sight spot on. The Earth is rotating, the moon is rotating and moving. It's a very complex piece of mathematics to keep it all in sight.
That's right. And while it's transferring from one to another, as it's going across the Atlantic Ocean or whatever, or Pacific, there's going to be a huge gap in the signal before it's picked up again by the other antennas.
Yeah, of course it is.
Here's an example of how accurate you have to be. 1 arc second equals the size of a dime that you have to hit at 4 kilometers.
That's pretty impossible to do visually, let alone with some sort of non-existent motor driving it. We haven't found this motor. Now, I think what Raza is getting is abuse from one of the NASA fanboys who are determined that we have identified a problem with the antenna on the lunar rover. And he is now saying this is how they solved it. But we don't see any evidence. You pointed it out, Robert. There's no evidence of any servo motors to drive the antenna. It's just not there.
And they said it was only on Apollo 17. Just on that rover is what this fellow said. And that's where that article came from. Yeah. But when we go to NASA's own PDF and we pull the Apollo 17 rovers up, all pictures of them, the ones where they were at the other stations, 2, 3, 1, station 1, when they set it up, they have no excuse. Because by the time they get out for the second traverse, that dish has to be set up along with the motors if they're going to have motors on that dish. And we don't see any motors in any of those photos, and no motors in the PDFs. No motors, no servos, no control wire going up to it, nothing.
It's not possible.
You'll never see the antenna almost vertical where it needs to be to even be close to the Earth.
Of course,
Right? It's usually on about a 45-degree angle. And of course, they also have shots of the Earth that are down at 30 degrees, just above the mountains and whatever. And it's not going to be there. It's going to be above 80 degrees over your head, depending on which Apollo mission you're on, located on the lunar surface. But it's going to be between 80 and 90 degrees, almost vertically above you. It's where you're going to find the Earth.
I mean, surely any halfway decent astronomer can identify where the Earth is when viewed from the lunar surface. Whether there's a human there to do it or not is irrelevant.
Well, NASA's lunar surface is quite a bit different than reality.
Oh, yeah.
The one that they took at Flagstaff is quite different. They can have the Earth can be low in the sky, high in the sky, all over the place. And that's the same as when they're shooting back. Even the size of the Earth changes dramatically. Like when they were so-called halfway pasted in the window. Look at the size of the Earth and the distance they were away. The damn thing should be huge.
Of course
It's a little tiny thing. It's the same size as what we see the moon at.
But the Earth is bigger.
And they were so much closer. I mean, it's the same size as what they shot when they're so-called on the lunar surface. They're supposed to be, what, out 200,000 kilometers when they shot that? Almost halfway. The thing should be gigantic. Here's this little wee thing in the window and the hairy arm running across it and all of this stuff, right?
Another thing, too, is that not only was there the arm in front of it, but it's always full of clouds. You see, what happened, I did a video not too long ago where I was showing a video of Australia as the ISS was going over it. Finally, we get a clear shot. The lens on it had such a zoom on it that now Australia is the size of the entire surface of the Earth on one side. It's massive because they have that fisheye lens on it. And guess what, folks? It's round. So now Australia is round just like the Earth, the whole thing. And it's because of that lens. You see, then we look back at the one image from BART, and guess what we have? The same thing, clouds. Well, for all we know, that could just be one continent that we're looking at under those clouds. But the problem is you don't know that because it's just a transparency pasted to the window.
Well, you know what you could do with those fisheye lenses is if you put lines of latitude and longitude on there, if they're claiming that's the whole Earth, you'd be able to measure how much larger they have made Australia, because you'd have all your time zones. So like it'd be 10 time zones going across there, right? Like if you put the lines in there, if that's supposed to be half the surface of the Earth, you could put your lines of latitude and longitude in there and you'd see how much bigger they made it.
But of course, when they were doing it back in the 1960s, nobody at NASA thought that anybody would take the time, trouble and care to actually work out the reality of viewing Earth from the lunar surface. And it's a very specific piece of geometry, which you can calculate. It's not rocket science, this is just basic optics. And if you start looking into it in detail, which we've been doing, and quite a few people have identified the problems, you're going to get a few NASA fanboys coming along trying to dispute what we're saying. But what they're saying doesn't add up to reality. It's just their imagination.
I think one of the biggest problems with what they did for simulations, all of the simulations, there was so much effort trying to get a Saturn V rocket off the ground.
Yes.
That thing could not blow up. It had to launch. 7 times it had to launch. It could not blow up. That was their main concern. That was 100% of their focus was to do that, because the entire missions would fail if that part of their project, if that failed, if that blew up on the launch pad or within visual range. They had to get that out of sight first. It can land in the Atlantic and do it, whatever. There was so much energy and time focused on that when you start looking at the simulations, they're more of an afterthought. They didn't have their best guys on that. They had their best guys trying to get that rocket off the ground. And they go, how's it going with the simulations? Oh, well, let's take a look at this. They look at it quickly and go, hey, that's great. You know, Go
Yep.
back and do another docking and undocking and see if you can do it any better, right? Get out to Flagstaff and shoot Hadley Rill for us and shit like that. And get that gantry crane out there and see if we can get that lift off a little better. That's about all they'd be doing. Like, run the film again, see if you can do a better shot of it. We'll pick the best ones. Oh, get that simulated shot there that Bart's showing, right? Oh, hey, that looks great. They never took the time to look to say, hey, that Earth isn't nearly the right size. And what's that hairy arm doing in the picture? They didn't look at it that closely. And even when Kip Teague took all of the photographs and started uploading them, well, he's a computer guy. The computer equipment that he had at the time, even the best of the best equipment to scan and upload that many photographs, 5,700, whatever, he had to scan. He wasn't even looking at what's in the photographs. He's sitting there running the software on there with a big drum scanner and going, I need more hard drive, even though he's scanning 1 megabyte files. Those were huge in 95. That would take 10, 15 minutes of photograph to put in there or more. That's if you had really good equipment. If you put a drum scanner at 48-bit in 1995, you can come back the next day because it's going to take that long.
It would take a long time to scan them in the mid-90s, and they were desperate to get them uploaded because the internet had come to the point where it was possible to upload them all. So they had to get them online. But they didn't look at the pictures. They just had the number of images that they had in their secure location at Houston, and they took those, scanned them, uploaded them, but they didn't look at the content of the picture. And that was the mistake they made, because it's now irrevocable. They've uploaded them and said, this is what was done. We've now identified so many anomalies within those pictures, and then start looking at the technical side of it. And it gets to be ludicrous, the number of problems that they've omitted to deal with, irrespective of where the pictures were taken, whether it was Cannon Air Force Base, Flagstaff, Cinder Lake, all these locations they could have used because they had to produce a lot of pictures.
What I'm really wondering about when I take a look at Lookout Mountain Studios, they had quite the camera crew inside of that place shooting a lot of footage. I have video of it, the films of these guys with the cameras and everything else being set up in there and filming. It makes you wonder, what were those guys filming?
Probably filming one of the models, because Lookout Mountain Laboratory, though it's quite a large place, wasn't that big. If you're going to film at life size, at human size, with the lunar lander, it's 20 foot across, about 20 foot high. It's a big piece of kit. It's much easier to film it using a well-made model. And there are plenty of people around who could make those models and be very realistic. And they hadn't expected 50 years later that people would dissect the pictures, look at in detail at these models and say, no, it doesn't add up. It's not correct. I mean, what you've identified there with the Apollo 17 antenna, it makes no sense that you can drive around on a rough surface, which was deliberately rough so that you'd think you're on the moon, transmit that image to Earth from a small 2 foot wide, 3 foot wide antenna on the Lunar Rover back to Earth. It makes no sense. I mean, one of the things that we see in the UK is the Grand National. That's a horse race, jumping over big fences. And it's transmitted live. And that is done from moving vehicles with the camera on the vehicle, transmitting that picture direct as a live broadcast. And it's transmitted from the racecourse at Aintree, where the Grand National is held, up to a satellite, and then back down to Earth to be received by people on Earth, right across the UK, and then transmitted around the world. But the camera that is being used is very secure. It's not bouncing around. It's got the stabilizers to make sure the camera is maintained with VR so that you get a steady picture from a moving vehicle. It's a very complex thing to do. And then to transmit it live, it's only happened in the last 20 or 30 years they've actually done it live from moving vehicles. And you see pictures of these moving vehicles, the camera mounted on a vehicle following the horses. Yeah.
But as far as this goes, I mean, these guys that are saying, oh, well, the dish had this on it and that on it. Well, I'm going to show you something, Marcus, because this is what you said in the last video, and it had to do with just that. So here we are talking about these fellows from the NASA fan club, and how when we make a mistake, they crucify us. But the thing is that if we make a mistake, we will make a video showing where we went wrong. These guys won't do that, and NASA won't do that. So I used this for an example in that PDF, and I said, right after you said that, yeah, well, and NASA doesn't make mistakes, I'm going, well, there's mistake number one in this article here, because there's no servos, there's no motors, there's no control wire anywhere on that dish. And that goes for 15, 16, and 17.
That's right. Yeah. So let's put out this challenge to the NASA fanboys who claim that this antenna on the Lunar Rover has servo control motors, has accurate aiming. Produce the documentation to demonstrate the truth of your statement. That's all we ask. Produce the documentation. Don't just assert it. Don't just say it because we have identified this anomaly. Don't just claim that NASA had a servo motor to make sure the antenna could point in the direction it required to be pointed in when it was moving across the alleged lunar surface. Produce the documentation to show what you claim can be proven. Otherwise, shut up, go away and do something else. It's noticeable from the comments that many people make about the standard of videos that you're producing, because it makes it so clear that what we're discussing, what we're talking about, can be backed up with hard physical evidence, which you do.
Here we have Pete Conrad 2077. And so we're talking about temperature on the lunar surface. And I'm saying, well, there is no temperature on the lunar surface until you put something in it. It's a vacuum. And he says, oh, you've almost got it. And I says, okay, then answer me this. What temperature would you get if you took a thermometer? I don't care if it's a mercury thermometer or an infrared thermometer, and you aimed it at the lunar surface when the sun was at high noon, let's say. So what would happen if you put the thermometer and pushed it into the soil? What temperature is it going to read? This is what I asked him. What temperature is it going to read? Let's see what he has to say about that. Because he's going on about how university students and they don't misunderstand physics, but Apollo deniers do. So Pete Conrad says, yes, you've almost got it. The sun only heats up the very top surface of the moon, so therefore not that much mass to hold heat. On Earth, it's entirely different where you have an atmosphere. You don't have an atmosphere on the moon, and so most of the heat radiates back away. That's not the question I asked him. I said, what would the temperature be if you pushed the thermometer into the soil? Why don't you guys ever answer the question?
Well, the fact of the matter is when it hits the soil's going to absorb it and it is going to penetrate.
Well, isn't that what radiation is?
Yeah.
Yeah.
Yeah, that's what I thought. So let's bury a steel plate 4 inches underneath the lunar surface. What's going to happen to that steel plate when the sun strikes the surface?
It's going to heat it up.
Right.
Absolutely.
What about conduction? No, there's no convection, but what about conduction and radiation? Oh my God.
This video just came out one day ago from Astrum, and it's on water on the moon. This whole thing is talking about it. And of course, the water they so-called detect on the moon and what it's going to be good for. And then they were talking about what they're basically finding is what they call hydrolux, which is hydrogen and oxygen mix, which can be used, of course, for rocket fuel and stuff like that. And the one comment he made about water on the lunar surface is it's like 100 times less than what's in the Sahara. And then they plan on sending, some probes to the south pole of the moon, where there's a couple of large craters where they figure there might be water. However, I just want to know how, if it's minus 173 degrees Celsius, how this equipment and the batteries are going to be able to operate. And considering that they're going to drop it down into a crater that never gets any sunlight, their solar panels aren't going to work. They're going to have some way to keep this vehicle warm all the time and use a hell of a lot of energy to overcome that. And then If they're in a crater, how are they going to send a signal?
Well, it seems like the NASA engineers have another problem to solve, doesn't it? Doesn't it? Doesn't it? Doesn't it?